Okay, it looks like we're going to begin. It's 6:45 already. So when other students join, we will bring them in. The first problem we're going to solve is to respond to Omar Poyo's question about what to do with the machine uh, problem. Okay, so I'm going to bring that up. I will share the screen, and then I will put that in the PowerPoint slide. Okay. I'll share my screen. And I'm going to begin with the machine test hypothesis. I'll move it up. All right. Now, our good friend Omar was asking what we need to do. Here is the question. Okay, here's the question. All right. It says that use the test of hypothesis to resolve the question whether each machine is producing at its 25%, at 85% of more of its rating. Now, let us remember that machine number one, expected output equals 700 units. That is the expected output. So I'm going to use that one to illustrate, okay, for 700 units. Then machine two, expected output, what was that, 200 units? Okay, that is the expected output. Now, using this information, what is 85%? 85% of output is equal to 595 units. So now that is what you're going to be testing for. You're going to be testing for 595 units. All right. The same way, I'm going to take that out. All right. The same way for machine number two, 85% will be equal to 170 units. So you're going to be testing for 595 for machine number one and 170 for machine number two. Okay. So what is it then that we have? What information do we have? I'm going to indicate the information we have. Okay. Information for hypothesis testing. All right. So let's pull up the information that we have for this problem. The information we have for this problem is here. All right. So the output level that we expect for this machine is 595 units. Okay, we expect 595 units. So that is your mu. Okay, that's your mu. So let's, that is the expected population. Okay, so mu is mu is 595. Oh Lord, what's going on here? All right, so that's our mu. Now the hypothesis that we're supposed to be testing so we have to create another slide. So we have that information, hypothesis, testing procedure. Okay, we have that mu, what we expect, is 595. That's what we're testing. So our null hypothesis H naught will be that mu is equal to 595. The alternate hypothesis will be that mu is greater than 595. Is that clear so far? Hello, guys. Everybody still there?
Yes.
Okay. Is it clear so far what we're supposed to be testing?
Yes.
Okay. All right. So now our level of significance, we choose level of significance equal to 0.01. So I'm just using that arbitrarily, okay? And this implies that Z star equals to 2.33. Now, we already learned how to look for Z star. So let's not spend time in that. But if you still don't know how to look for Z star, then you should participate in my general office hour on Thursday. Okay? The general office hour on Thursday, anybody that wants to participate has to notify me so I can send you the link. Okay? If I send you the link, you can feel free to give it to anybody else. That's up to you. Now, we have to calculate calculate Z if your sample is large sample, or T if you have a small sample. All right. Now, for this problem, the T or the Z has been given to you. Okay. The T that you see there, take it to be a Z, because this is a statistical software, so it uses some standardized symbols. So don't claim that it didn't give you a Z or that they gave you a T and therefore you cannot do the problem. What it does there is that it uses some standardized symbol, and so you calculate the Z for this problem, and I'm going to, are you seeing my PowerPoint slide? Hello? What did I hear?
Yes.
You are seeing my PowerPoint slide?
Yes.
Okay, very good. So I'm going to pull up the information from so when we pulled up the information, you can see here a T of 3.585. So let's call it a Z so it doesn't confuse you. You see that? So you have the Z that it gives you is 3.585. Okay. So I'm going to take that. That is the Z that you are given. So for this problem, for our example, the calculated Z is equal to 3.858. So what is the decision rule? The decision rule is if Z is greater than or equal to Z star, we reject the null hypothesis. All right. So now for this problem, compare Z to Z star. Okay. Z of 3.858 is greater than Z star of 2.33. Therefore, what do we do? So tell me, can somebody give me that answer? Therefore, we do what? Hello, I want an answer.
Therefore, we reject the null hypothesis.
Therefore, we reject the null hypothesis. The answer is very simple. 3.858 is greater than 2.33. Therefore, we reject the null hypothesis. Okay. Therefore, we reject the null hypothesis. What does it say about whether this machine is producing according to its capacity? What does it say? What was the original problem? It says use the method of hypothesis testing to resolve the question of whether each machine is producing according to its rating. Okay, if a machine is producing 85% or more, then that machine is within acceptable performance efficiency. So machine number one, is it within acceptable performance efficiency? Hello? Somebody give me an answer. Hello, hello, hello.
I think it is, we accept that the machine produces more.
Okay, so now you reject the null hypothesis. You are saying that the machine is not producing at 595. Since you reject the null hypothesis, all right, you conclude then that the machine is producing more than 595. Am I correct?
Yes.
Good. So since you reject that it is producing 595 or less, you are now concluding that it is producing more than 595. And if the machine is producing more than 595, then you must conclude that the machine is performing according to how it is rated to perform. Am I correct?
Yes.
Okay. So that is the whole idea. The whole idea is not to do a mathematics and tell me that you reject or not reject the null hypothesis. The whole idea is for you to make a management decision, a business decision about this machine. Okay? So, and let me modify this a little bit so that our issue is very clear. Okay? So a machine is not producing according to its rating. Okay, and so we can okay. So machine is within its rating. Okay. Let me make this a little bigger. It's not within. Okay. Or it's below. Okay. So the machine is not within its rating or it's below it. Okay. You can say that it's below. So this is what you're expected to do to be able to make a decision, a business decision, based on the numbers. All right. So is that clear what you're supposed to do? Hello?
Yes.
Okay. I have Mr. Bamisile. Hello? Are you there?
Yes, Professor, my service is terrible.
Okay. I
It's
expect
going in and out.
I expect to be hearing hallelujah from everybody. And Simone is there. I'm not hearing anything from Simone. Okay. So now this is one population hypothesis testing, which is what we did last week, and we illustrated how to use SPSS to do it. In this particular problem, you have been provided all the summary statistics. You've been provided all the summary statistics. Okay. In a normal problem, you're going to be given raw data, and you can use Excel, that raw data, or you can use SPSS, and this is what we illustrated the last time. You can use Excel, use SPSS. So now we're going to go to the next step, which is two population hypothesis testing. All right. So in two population hypothesis testing, you are comparing two populations. Okay. You're comparing two populations. For example, is there a difference in the value of real estate sold by male agents compared to female agents. So you're now looking at two populations, the population of male agents and the population of female agents. So you now want to compare them and see if there's any difference. Is there a difference in the mean number of defects produced on a day between the shifts at one location and the shifts at another location? All right, or between the day shift and the afternoon shift. Okay, so you're comparing those who work during the day to those who work during the night. Okay, during the afternoon. I don't know why they call day and afternoon shifts. I don't know if day means morning. So let me say morning shifts and night shifts. Okay. All right. So, and this is an example of what we mean by hypothesis testing for two populations. All right. So how do you go about that? Okay. The way you go about that is very simple. In order to do a hypothesis test for one population, you calculate the mean, you calculate the standard deviation, and you choose a level of significance. And so when you're doing a population test for two populations, you go through the same thing. You calculate the mean for one population, then you calculate the sample mean for the second population, then you calculate the standard deviation for one population, and you calculate the standard deviation for the other population. So in that way, you use that to test the hypothesis whether the two are equal. The two population means are equal. So now let us proceed, look at an example. This is an example here that is given by your authors, but we're going to look at our own example using our own data, all right? All right, so I'm going to look at the an example using data from houses in a neighborhood. Okay, there are two kinds of houses. Okay, two types of houses. Okay, one family versus two family houses. These are the two types of houses we have in a neighborhood. Okay. What are we going to compare? Okay. We're going to compare the ages of the houses. Let me put it clearly. The average age of the two types of houses. That is what we're going to compare. We're going to compare the average age of the two types of houses. Let us take, for example, I'll give you an example here. Okay. And the example will be, what if in this neighborhood, originally they began to they began to construct one family houses. And then at some later time, they began to construct two family houses. So what you're going to find out is that the average age of the one family houses are going to be older than the average age of two family houses, or vice versa. Okay. So what do we do? Okay, the steps, as usual. We state the null hypothesis, and then and alternate hypothesis. Okay, we calculate our sample mean, sample standard deviation. Okay. Okay. And we note sample sizes. Okay. And then, of course, we calculate Z. We calculate Z, and then we compare to Z star and apply decision rule. Because before you calculate Z, we select level of significance. And of course, your level of significance will decide your Z star. Okay, these are the steps. Okay. And I hope that these steps are very, very clear to you. So then how do we proceed with this particular problem? I'm going to proceed in 3 steps. I will proceed in 3 steps, okay? I'm going to proceed with giving you summary data, okay? I'll proceed, first of all, by giving you summary data. All right, so let's, so what is the summary data here? I'm going to pull up some summary data and I'll provide it. All right. So here is the data. There's the data. Hope you're seeing it clearly. Okay, guys, are the numbers clear? Hello? Everybody hearing me? Hello? Simone, are you there? All right, I'm just going to proceed. I'm not hearing from anybody.
Sir, I'm here. It's just that we have some noise in my background because they're moving out.
Okay.
So you'll see me via text, yeah.
Okay, so you're hearing me because I don't want to be talking to nobody. Or at least if I know there's nobody there, I'll just give my lecture and just move on.
Okay.
Okay, without worrying whether anybody's understanding me. Okay, so here I have summary data. After I do the summary data, then I'll do an SPSS, and then I will do MS Excel. So once more, you have summary data on, say, the age of houses. There are 44 two-family houses and 49 one-family houses. The average age of the houses in two-family houses is 49.89, and the average age of houses for one family is 62.8. And then you have standard deviation of 29 and standard deviation of 20. So now we're going to apply the method, okay? And I'm going to write the summary statistics down, okay? So X bar for two-family houses is 49.89. The standard deviation is 29.07. And X bar for two-family houses is 62.8. For one family house, 62.8, and the standard deviation is 20.04. So we're going to write that down and go through the steps. Okay, I'm going to write it down and go through the steps. Okay, the steps for hypothesis testing. Two populations, age, average age of houses, average age of houses, okay? So we're comparing two populations, one family house and two family house. All right, so the hypothesis will be that U1 U1 is equal to U2. This is not correct. You know, hypothesis will be that U1 is equal to U2 All right, so that would be there is no significant difference in the average age of one family houses compared to two family houses. That is the null hypothesis. Okay. Or you can simply say that it's better to put it that way, that mu1 minus mu2 equal to 0. That way, if there's no difference between the average age of the two houses, then mu1 minus mu2 is equal to 0. And the alternate hypothesis HA will be that mu1 minus mu2 is not equal to 0. All right. So you're saying there is a significant difference in the average age of one family house compared to two family houses. All right. So this is what you're saying. This is the way you state the null hypothesis. Okay. First is that there's no significant difference in the average age of houses. Okay. And then the alternate will be that there is a significant difference. Now you can state the alternate hypothesis so that you can have this as greater, or you can have it as less than, strict equality sign. All right. So once you state that, the null and alternate hypothesis, then you can choose the level of significance. And I'm going to choose it here so that maybe we can see it all at once. I'm going to make the choice here. Okay. I'll make the choice here. And level of significance, we choose. Okay. Let us say we are testing at 0.005, which means that our Z star will be equal to 2.576. That will be our Z star. All right. And again, if you have forgotten how to select your Z star, then you should come to my office hour on Thursday, and we'll go through it. And I'm going to hold the due date for the assignments. I'm going to postpone the due date for the assignment a little bit more so as to give you time to be able to submit the assignment. Okay? Because I want everybody to do well in this class. All right. So now that you have done this, we're now going to calculate the Z for the problem. Okay. So how do we calculate Z for two population hypothesis test? Okay. So we calculate Z for two population hypothesis test. Okay. We'll calculate Z for two population hypothesis test. And Z is equal to, for two population hypothesis test, will be X one bar minus X2 bar divided by square root that's 1 squared. If you're going to walk, okay, over and 1 plus S2 squared over and 2. Supposed to be and 2. No, why that? Nothing in S. I'll try once more. Let's see if it's going to go. All right. And I'm gonna have to take this from something different. That we have done elsewhere. Okay, let me try once more. Is more trouble. That's 2 squared. All right. Okay, so this is what we're dealing with. This is how to calculate Z for the two population test. So now that we have this, we have X1 bar, okay? We have the information here. X1 bar is equal to, so we can take this. And so X1 bar is 49.89, okay? 49.89. And X2 bar is 62.8.8. All right. And here we're going to use the absolute value. Okay. The absolute value. So let's make that clear. Absolute value. All right. So S1 and S1 is 29.02. So S1 squared is 29.82 squared. See if that's gonna happen. 29.82 squared. Okay. And S2 squared is 22.04. Okay, 20.04 to the power 2. All right, divided by N1, which is 40. This is 49, and that is 44, which we got from the statistics here. 44 and 49. I put it the other way around. This is 44, and that is 49. So once we have this, we can now do our calculations. Okay, absolute values. And so, what do we have? What we have is 49.89 minus 62.8. We're going to use the absolute value. So let's do a little calculation here. $62.8 minus 49.89 is the absolute value is 12.91 divided by the square root of and so this the square of 29.82. So take 29.82 times 29.82 is 889.234. 889.234 divided and that one, the other one, 20.04 times 20.04, 401.6016, 401.6016. You divide this by 44 and you divide that by 49. Okay, so what do we have? Okay, what we have again is 12.91 divided by over 49 is 8.196. 8.196 plus 20.209, 20.209. Again, what do we have from that? As a matter of fact, should be plus so what we have is 12.19. Divided by the square root of 20.2 on 28 point. Um, 28.405 is 5.329. 5.329. And so what is the result of that? The result of that this is not 12.91. You guys should correct me when I am wrong. You guys okay? 62.8 minus 48.9. Okay, that's correct. Okay. Okay. 12.19 over 5.32 is 2.29. 2.29. So this is our Z. Okay. So Z is equal to that. All right. $2.29. So now we have to apply the decision rule. Okay. If Z 2.29 is greater than or equal to Z star 2.576, we reject the null hypothesis. Now, as we can see from the results, show that we are not able to reject the null hypothesis because Z is less than Z star. Okay. So what is the conclusion? What is the conclusion? The conclusion is that there is no difference in the average age of houses. Okay. There's no difference in the average age of houses. The implication is there is no difference in average age of houses in the two neighborhoods. That is the conclusion that we reach. All right. So I have done the hypothesis test here using summary data that is already given to you. Okay. Now, what if you were not given all this summary data? How are you going to do it? You can do this using Excel. You can do this using SPSS. Now, if you do this using Excel, you just have to calculate your own mean. You have to calculate your own standard deviation, which we already learned in Statistics 1, which you have already learned in your first statistics course, how to use Excel to calculate the mean and how to use Excel to calculate the standard deviation. That is very simple. But you still don't know how to use SPSS to do it in a very easy way, okay? In a very easy way. So I'm going to go ahead and use SPSS to do this problem, okay? Now, how to use SPSS to do the problem? The steps, okay, is to go to Analyze, okay, and then you take you select Compare Means, okay. You do okay, then you select Independent Sample t-test. That's what you select, Independent Sample t-test. Then you select your variables, okay. Select your variables. Select variables to test. All right. Once you select the variables to test, you see a box. You see sorry. Okay. You see a box. Okay. And the next thing is you select groups. Okay. The group variable. And I'm going to go through this. The groups to be tested or to be compared actually. Okay. Select the groups to be compared. And you type in the groups. Then you select the options. Okay. You select the options. The options, that is to say, the level of confidence, okay, that you're testing at. Okay. The level of confidence. In that way, for example, 99% confidence is the same thing as a 0.005 level of significance. Okay. The steps. Put this out. So these are the steps, so that when you try to practice this on your own, you can use these steps. Okay. So let us now look at how we apply the steps. I'm going to share the SPSS process. Okay. Here is the SPSS process. So I'm going to pull up the file, the SPSS file that has the data. Okay, I said you go to analyze, you compare means, you do the independent sample t-test. So you select the variables. I'm going to select the age of houses. Okay. And then I'm comparing 1 or 2 family houses. So I take that. And 1 and 2 family houses are defined as 0 and 1 in the data set, which you see here. You see the zeros and the ones here. And the option is for 99% confidence interval. And you say, okay. So once you do that, what do you see? You see the results here, okay? And you see the t-values. The t-value is 2.499. So you compare this 2.499 to your z-star that you select, which is 2.576. Once you make that comparison, then you make a decision, okay? So that is how to use SPSS to do the test. It's very simple, but you can also just use Excel. But you can also see that the summary statistics are already here for you, so that you don't have to use Excel to calculate the summary statistics, the standard deviation, and what have you. You don't have to go through that. So again, I will pull up the PowerPoint slide, and you will see that the summary statistics are already calculated for you using SPSS, and you just plug it in, okay? I'd rather put it in MS Word first before I plug it in. Okay, so these are the summary statistics. All right, so you can see it's quite simple. Okay, it's quite simple. And so you can use these summary statistics without having to use Excel if you just know how to if you don't know how to interpret the SPSS table, which I would like to interpret next time, you can just use these summary statistics that are here, and it's very simple. All right. Okay. So that is the end of my presentation. Do you have any questions? Hello. You have any questions? All right. I take it you have no questions. So I'm going to post this. All right. Thank you very much. Okay. So I'm going to post the lectures on what do you call it, in YouTube, and then notify the class about it. And so that if you still have any questions, then notify me that you want to participate in the Thursday general office hours for all students. And you can bring up questions that you don't understand from here. Is that clear? Okay. I take it that it's clear to you. And so I'm going to end the lecture, and then I will post this for you, for the whole class in YouTube. Are we all right? All right. So have a nice evening. And I'll see you guys next week, Monday, or if you have questions, you come in on Thursday. All right?